Welcome, fellow car enthusiasts, to this comprehensive and in-depth exploration of the fundamental differences between naturally aspirated, turbocharged, and supercharged engines, which are key to understanding modern automotive performance. In this video, we'll delve deeply into how each of these engine designs uniquely impacts not just performance and efficiency, but also the overall driving experience that every car lover cherishes. To start our journey, let's first understand the naturally aspirated engine, commonly abbreviated as not applicable, which represents the classic approach to engine design. These engines operate by relying solely on the natural atmospheric pressure to draw in the air needed for combustion directly into the chambers, without any additional mechanical assistance. They are renowned for their smooth and linear power delivery, providing immediate and predictable throttle response, and often producing that raw, distinctive engine sound that purists love during spirited drives. Although generally simpler in their overall design, with fewer complex components, not applicable engines tend to produce less power per liter of displacement when compared to their more advanced forced induction counterparts like turbos and superchargers. Now, let's transition our attention to turbocharged engines, which have become a highly popular choice among enthusiasts looking to significantly boost performance in a compact package. At the heart of a turbocharged system, turbochargers harness the energy from hot exhaust gases to spin a turbine wheel, which is connected to and drives a compressor on the other side. This efficient compressor then forces a greater volume of air into the engine's cylinders under pressure, allowing for a much more substantial increase in power output during operation. One of the primary advantages of turbocharging is achieving a substantial power increase without needing to enlarge the engine size dramatically, and it often leads to improved fuel efficiency under normal driving conditions. On the downside, turbochargers can experience what's known as turbo lag, which is that noticeable slight delay in power delivery while waiting for the turbine to spool up to speed from low RPMs. Finally, rounding out our discussion, we arrive at supercharged engines, which offer yet another effective method of forced induction for enhancing engine capabilities. In contrast to turbochargers that rely on exhaust flow, superchargers are mechanically driven directly by the engine's crankshaft through a robust belt system, ensuring constant operation. This direct mechanical connection delivers instant boost pressure right from idle, completely eliminating any turbo lag and providing that exhilarating immediate power delivery when you press the accelerator. As a result, superchargers provide consistent and reliable power delivery across the entire RPM range, making them particularly ideal for applications requiring sustained high performance driving on tracks or highways. However, the trade-off with superchargers is that they require the engine to consume some of its own power to drive the unit, which can lead to slightly lower overall efficiency compared to the more exhaust-driven turbochargers. In summary, each type of engine, naturally aspirated, turbocharged, or supercharged, brings its own unique blend of characteristics that cater to varying driving preferences, performance needs, and even sound profiles that enthusiasts debate passionately. So, whether you prefer the raw, unfiltered feel of a naturally aspirated engine, the efficient boosted power surge from a turbo, or the instant, tire-shredding grunt of a supercharger, the diverse world of internal combustion engines remains endlessly fascinating for all of us in the automotive community.